Hi there. Hello, everyone. My name is Randi Williams, and I'm currently a PhD student at MIT. And today I will be both the moderator and the panelist talking about my work in AI education that I've been doing for the past few years. And I apologize, I don't have one of the gorgeous backgrounds behind me, but I do have these nice slides, so you can sort of use that to see what I'm talking about. So I've been working for about the past 4 years trying to bring more people to the table when it comes to AI. And specifically, I've been working to help grade school children become AI literate. I've been doing this work as a student at MIT, but in 2019, I was honored to be a LEGO Papert Fellow. And a LEGO Papert Fellow is a research graduate student who is honored for being at the intersection of creativity, play, technology, and learning. And I'd say that pretty much sums up the work that I've been doing, but also what my passion is in general in life. So from a young age, as you can imagine, I've been pretty interested in technology. In particular, I thought that using technology was all about playing those computer games like on Disney Channel or Cartoon Network or on board.com. And one of my favorite games is called Do Not Press. And so it features this great big red button that says do not press, and of course you press it. And as you press it over and over, it gives you these like increasingly obnoxious responses, and at some point the ball starts like moving around the screen, or it multiplies itself times 100, and I just thought it was a lot of fun. Now, around the same time that I was learning about this do not press game, I also was learning about the animation functions in PowerPoint. And so it wasn't quite programming, but I was able to use those to recreate some of these games and then entertain/annoy my friends and family with all of my recreations of technology. And so when I think about children growing up today, I very much want them to have that same experience of playing with technology, finding joy in it, but also having the opportunity to recreate it and to make it their own. The thing, though, is that the technology that I grew up with is not the same technology that children today are growing up with. Children today are growing up with technologies that really play a different role in their lives. The technologies can speak, they can express emotions, and they seem more alive and more intelligent, artificially intelligent, than the ones that I grew up with, and that most of us grew up with listening to this talk, certainly. And so to explore this, to explore what was happening between children and their technology, as any PhD student would do, I ran a study. So I got several dozens of children from the area into a room with a whole bunch of different artificially intelligent devices. There were toy robots, there were chatbots, voice assistants, Alexa, and all of these things. And then me and my lab mates, we just observed them. We wanted to see what was happening. We found a couple of interesting things. First, children reacted pretty strongly to emotional disclosures from the devices. So if Alexa was like, I'm happy and I'm so happy that I'm playing with you, then the child would immediately react and respond to that in a lot of the same. So it's interesting to watch technology really cause children to express emotions. Then the next thing was that children have very high expectations of the devices. So because they could talk, fluently, because they could make decisions and get information, children were like, oh, well, maybe you can also eat. Maybe you also have a whole personality and a whole life story. And it was fun to watch children push the buttons on these devices and try to really figure them out, almost in an ethnographic way. And then finally, we noticed that children kind of treated each device as a separate being. And so by that, I mean, there was one student who child, who I remember in particular, who we put an Alexa in front of him, and he was like, oh, this Alexa is really cool. At home, I have a white Alexa, but this Alexa is black, so I'll have to go ahead and get to know her again. And I just remember sitting there thinking, well, like, it's not exactly how it works. There's something like the cloud, and the cloud makes all the Alexas have the same personality. And I couldn't figure out how exactly to explain it to this 5-year-old. And honestly, it's kind of a disservice to them because even though the 5-year-old was old enough to fully interact with the technology and use it to find information, they, unfortunately, because of the way the devices are set up, could not understand them. And so in this vision that I have where children can not only use but interact and tinker with technology, we had to do something to change that. And so from there, birthed my master's thesis, which is called Preschool-Oriented Programming, or Popbots. Here's a quick video of what it was like. And unfortunately, you're not going to be able to hear it, so I will just talk through it for you. So the ultimate goal of Popbots was to find a way to use artificially intelligent technology to teach children about artificially intelligent technology. By children, I literally mean preschoolers. I worked with 4, 5, 6-year-olds. Actually, almost 100 of them were in the local area. And what I had children do was not only build with Lego or program these devices, but also actually get the chance to interact with them. So they got to see the device get better at playing games by playing against them. They taught their robots about things in the world, such as foods. This is what the interface looks like. As you can see, the robot has this fun creative face that's based on some of the robots that we build in our lab. The body is Lego. And on the right-hand side is the programming interface that I use with the children. There are no words because they were pre-literate, but what they can do with this is they can teach the robot about foods that are healthy and not healthy. So just now I asked the robot, okay, blueberries, do you think they're healthy or not healthy? And the robot said, oh, well, they're super sweet, like ice cream and chocolate. Maybe they're healthy? Unhealthy, sorry. And so I said, no, robot, it's actually unhealthy. And so as you can see, the goal of this was just to say that we really need to stop leaving people out of the picture and out of the conversation with AI and take a second to see how we can invite them in. What is the correct way to explain this, even to 4-year-olds, that make sure that they have a grasp on the technology too. One of my favorite stories of doing this work, in 2018, I got the chance to go to Mexico and teach a class of high school girls about computer science. And so it was this amazing experience where on Monday, we started learning about programming, programming JavaScript. And I told them about my favorite algorithm, which is Bayesian inference. And then on Friday, literally, this group of girls, they came up with a design of a survey where people could answer a few questions, and then it would point them to the political candidates who were most aligned with their values. So in Mexico, there are 9 political parties, or sometimes more, and it becomes very hard to engage civically because it's hard to get information about all of them. And so they used an algorithm they'd literally just learned about, prototypes using tools that they'd literally just learned about to make this huge change in the world. And, that's the goal, isn't it? We want to help children realize that they can use this technology to really change their world and to really have an impact on their world. The thing is that AI is one of those things where with much power comes much responsibility, right? So we don't just want to teach children about AI without paying attention to how we teach them and what we teach them. And so the 2 themes that really drive my work as I'm moving to talk more about the specific curriculum that I designed is first, the idea that I want children to become conscientious consumers. And that harkens back to the child with the Alexa who didn't know how it works. If children can interact with these devices, if they can use them fluently, then they should be able to know how they work so that they can make informed decisions about how they use it. They should know about privacy concerns, they should know about different trade-offs, they should just be able to understand it. And of course, this is not just limited to children, this is for everyone who might be using the technology. Now, the second thing that I hope for is to help children become ethical engineers of the technology. So engineers, because I want them to actually build and create this technology, but ethical, because it's not good enough to just know how to build it. You have to know how to reason through it. And when you look at my field, if you look at the field of AI, we kind of have an ethics problem. There's so many examples of algorithms that have been released in the world to solve all the problems that we find out perpetuate systems of bias and inequity that we don't even accept from other humans. And so how do these things get encoded literally into the technology that we're using to try to improve the world? And then on top of that, of course, there are tons of concerns around, just access to the technology, but then access to even the opportunity to learn about the technology. And so all of these things are important ideas that I want even grade school children to be able to understand and get a grasp on. Okay, probably sounds good, but how exactly do you do that? That is a great question, and I'm glad that you asked. So for the rest of this talk, I'm going to be sharing about how to train your robot, which is the middle school AI and ethics curriculum that I've been working on for the past year, and just a general overview of it and what it's all about. Children get the opportunity to build and program their own robots. They use kid-friendly interfaces for machine learning and AI, such as one in the middle picture, and they reason about ethical dilemmas within the technology that really is meant to help them not only build projects that they care about and that are meaningful to them, but also to be able to build them by thinking about the impact that they'll have on the world. How do you teach children ethics? If you think about it, we often don't even teach software engineers about ethics. It's a very hard topic to grapple with. So how do we make this not only relatable, but comprehensible to middle school students? Well, the first thing that I want students to understand is that technology is not neutral. And it's funny because before this, I looked up quotes about technology is not neutral, and I found like quotes on either side. So I'm saying that technology is not neutral. And by that, I mean that technology is designed with certain values, and it can be redesigned with certain values. And so when you take something that you can't imagine your life without, such as perhaps the iPhone, it's important to recognize that that technology was designed with certain values. And the values encoded in the iPhone have things like wanting to help people stay connected to one another, wanting to help people have constant access to information, and wanting to keep them safe by allowing them to almost always be able to call for help. However, in order to accomplish some of those good things, there are some negative consequences. And so one of the big ones is if you use it too much, you might damage your ears, your eyes, your hands. All these physical consequences can be very distracting from your physical surroundings, which is funny because it's like, it keeps you more connected, except for the people who are right next to you, those people less connected to them. And then finally, it can be addictive, and that almost worsens, that exacerbates the issues that you have to your ears and eyes and hands. And so sometimes in a class, I'll have students who are like, technology is the greatest thing ever, and I can't live without it. And then there will be other students who are like, technology is the root of all evil, and we can't have it. And my goal is to get them solidly in the middle, where they realize that technology, just like any other tool, can be used to address problems, to improve the world, to create change, but also with all of those positive possible impacts, we have to think about the negative impacts that can have, and we have to be able to design through them. We have to make sure that we don't just ignore the negative impacts, but we actually address them so that we can really elevate the good over the bad. Sounds cool. How do you do that? Well, we use tools such as this. This is called an ethical matrix. It was designed by Ben Metham, who did works in bioethics, and it's also an activity that is used in the AI and ethics curriculum that was designed by Blake Lee Payne. So we adapted this tool that adults have used for middle schoolers. So with this ethical matrix, I had students redesign Alexa. And Alexa is one of those things where students are like, oh, Alexa's great, we love her. But if you think about it, Alexa is really only designed for personal use in the home. Alexa in the school doesn't work as well. So how do we redesign this technology with different values? The first thing we have to consider are the stakeholders. Who are the people who are impacted by this technology? And students come up with things like, well, the students, teachers, parents, the company selling them. These are all different people who would care about how this technology is designed. Great, well, what do they care about? They might care about the apps that are available on this Alexa for School. They'll certainly care a lot about safety and privacy, and price could also be a concern and a factor too. And so once students have laid out, these are the stakeholders, these are the areas of interest, Then they can go through the chart and say, which of these things matter to which people? And so they sort of do that exercise and they can get an idea of what things might be most important. Now, the funny thing here is you might say, oh, well, most people seem to care about safety and privacy. Let's just design a lecture for schools to prioritize safety and privacy. And if you wanted to do that, then maybe a privacy concern you have is having like Alexa connected to the internet. So you don't want to do that. So you build your own server that can run all the Alexas just for the school. But that gets really expensive. And so then when you think about price, people do care a lot about price. And at the end of the day, if they can't afford it, it's not going to go into the school at all. So how do you sort of balance these two concerns? These are the kinds of questions that we have students think about as they redesign the technology. And then what's great is they apply these directly to projects that they create themselves. Here is one of those projects. So this, friends, is LibraryBot. B, who is a 5th grader and is actually not named B, but close enough, worked with her friends to design LibraryBot to go and fetch books for you in the library. And they really wanted to focus on helping people who might not be able to navigate the library by themselves. Now, a researcher, who will not name, just some researcher, came by and said, well, this is cool, but won't it take all of the librarians' jobs? B, ever prepared for this question, said no. We talked to the librarians in our school, and they said what they really value is being able to talk to people and help them find information. And so we intentionally designed the robot to not do that job. We intentionally designed it to support what the librarians do and to not replace them. Now, it's interesting because you think, well, do middle school students really care about unemployment? Yes, they do. Of course they do. They're watching the world that's happening around them. And it's so great to see how they can take what they learned in just a week and really use it to deeply think about the way that they design the technology that they think will help the world. Now, later on in this conversation, that researcher, again, will not name her, said, well, that sounds okay, but if no one is going and getting their books, then you're just promoting a sedentary lifestyle. And B kind of thought for a second and was like, huh, you're right. We'll put ellipticals in the front of the library to make sure that everyone works out while they're waiting for their books. Perfect solution. Regardless, the students, multiple students in this middle school classroom were able to take these ideas, these technical ideas and these ethical ideas, and deeply apply them to projects that, in my opinion, were just amazing, but also that students found really important to themselves. So it sounds great. We are teaching students AI, and we're teaching them about ethics, and everything is wonderful in the world. Except if you think about it, most people who don't know how to program really can't jump into AI. So how did we overcome that obstacle? I'm glad you asked again. So this is a version of the Scratch programming language. Scratch is an open source programming language. They allow people to build on top of it. And if you've never seen it before, just a quick run through is on the left are blocks of code that you can use to cause action in your program. You can drag those blocks over into the middle and stack them, snap them together, kind of like Lego blocks, to create programs or code that can run on the right in the stage. So this program in particular, when you blink your eyes, it'll cause that butterfly character to flap its wings up and down. So this is something that's very simple for new programmers, but also that's used quite a bit inside of the schools that we work with anyways. So that sort of gives you an idea of how we make things understandable to students. But let me show you another interface where we sort of bring in the machine learning part. And I have to apologize in advance because the screenshots were taken from a workshop that I did in Spanish. So you're not going crazy when you see some of the words in Spanish. That is real. All right. So this is a project that I made to train a classifier to tell if I'm touching my face or not, because in COVID-19, you're not supposed to touch your face. This tool is Google Teachable Machine. It's free, available online, and I'm very quickly training 2 classes. The first one where I wasn't touching my face, and the second one where I'm giving it different examples of me touching my face, sometimes even with both hands. Then we are able to train our model. So if you're very, very new to machine learning, you're like, what is this? What is going on? Well, if you've ever used Google Images and it sort of tells you like, oh, I think there's a cat in your picture or a dog in your picture, or if you're like on Facebook and it's like, I see your face, it's trained on different examples of what you look like, and then it uses that to generalize later. So now my model is trained, it trained in the browser, it took about a minute. Now it's recognizing, oh, you're touching your face, oh, you're not touching your face, and all of that. Works great. Now it's time to put it into Scratch so we can do fun things with it. So here's my Scratch project. And in order to put this model into Scratch, all I have to do is copy and paste the URL. So students have complete control of their models, pictures of their face are not floating around all over the internet, everything's happening right in their browser. And now that I've imported my model into Scratch with just a copy and paste, I can start to write a program. So in my program, I have these two hat blocks. One hat block is going to fire when I'm touching my face, and the other is going to fire when I'm not touching my face. So I'm going to have my little purple robot. When I'm not touching my face, it'll just say hello. And when I am touching my face, it'll say, hey, Randy, stop touching your face. And this is it. This is the code for it. Ready to go. Now let's see it in action. So I'm not touching my face. The robot says, hola. Touching my face, it says, stop touching your face, Randy. And you can see me going back and forth and playing with it. So I did not fast forward this video. I didn't cut out any important parts. It literally takes 5 minutes for students to train and then use their own image recognition models inside of a programming language that's very easy for novices to understand. Machine learning is just one part of AI. Arguably, it's one of the most in-our-face ones that we're experiencing right now. And so we're actively working on building more of these AI blocks for students. In this program, and how to train your robot, we also created a set of blocks to program the Bluetooth robot that you see in the top picture. We created a way for students to create their own custom text classification models. So when you think of like Alexa, like when you like want to ask it, how's the weather? You can ask it in a million different ways and it'll still know you're talking about weather. This is kind of the same thing. So no matter how you ask it to drive, if it's sort of in the vicinity of what it's been trained to recognize, it'll say, okay, you're probably asking me to drive. I already talked about the image recognition models, and you can see sort of all of them working together in that little GIF where I'm like, spin around and it starts driving, or I'm like, it's dark, and so it turns on the lights. What's most important about this, though, is that all of the tools are free. We avoided having students have to make accounts. All of it is browser-based, so we didn't want students and teachers to have to download things to be able to use it. And it's all completely compatible with Chromebooks, because all of the teachers and all of the schools were like, does it work on a Chromebook? So if you think about it, it's actually quite amazing to have sophisticated AI working on, on a Chromebook. What's also really important about this is that we wanted to make sure that we could access schools that usually do not get the chance to have this kind of technology in their classroom. So we mostly work with Title I, rural schools, schools that are in parts of the world that have different levels of economic development. Like, that is the tool that we're trying to build. And certainly it can reach schools beyond that, but that's who our target customer is. And so the only thing that has a cost, honestly, is the robot. And even then, that robot costs less than $40. And we're still trying to make it even cooler and cost less. So these are some of the big challenges that we're working on in this work, beyond teaching students about ethics and AI at the same time. So what do students do with these cool things? Well, I've seen students build literally dozens of amazing projects with all of these tools. And I apologize because animations on this sort of went backwards. So one example of the project, if you can kind of see it, is that students were responding to COVID-19 and social isolation. And so they created a project where they could ask someone how they're doing and then do the sentiment analysis. And if someone wasn't feeling great, then they'll tell them corny robot jokes to make them feel better. Another project, they wanted to help younger students learn math. And so they did a handwriting recognizer of recognizing different numbers, and then the robot will drill you on different math problems. You write your answer on a piece of paper or chalkboard and you show it to the robot. And then if you get it right, the robot like cheers you on and makes you feel good about yourself. And then the student who is after mine own heart, created a robot that brings you snacks on command. And so students were quite creative and quite personal with the kinds of different projects that they created. They were thinking about lots of different problems in the world, but also just building things that they thought were cool and fun. And ultimately, that is the goal. So as I kind of come to a close here, I just wanted to revisit what the main goal of this work is. We want students, all students, to be invited into the space because everyone has something meaningful to contribute to AI. We just need to make sure that they have access to it. We also want them to really connect with the work so that it's not just a subject that they learn and maybe they'll use it later, maybe they won't. Regardless of what they want to be when they grow up, we want them to know that there's something here that is meaningful to you. And more importantly, we want to ignite students' passions. We want them to look at this and say, hey, now that I've done this, I can go and do almost anything. I can tackle new challenges. But those are the values besides the actual things that we teach them that we embed inside of this curriculum. And so that's kind of a high order, like that's a lot of things that we're asking to do. And in order to make that happen, we partner with the people who are best equipped to do that. And those are the teachers and educators, the superheroes who are already in the classroom, who are already great at doing these things. And so to prepare teachers, we've created a suite of videos where we explain technical AI concepts to them and tie them to classroom activities that they can actually do with their students. How to Train Your Robot comes in the form of an educator guide that has like 50 hours of activity lessons, as well as different approaches they may take depending on what students' learning pathways may be. And How to Train Your Robot is just one of a whole suite of different curricula. And so that's pretty much what the project is. That's how I'm working to bring AI and ethics into classrooms today, right now. And so the key takeaways from this talk are first, that students should be empowered to understand the technology that's all around them and also to build it, because that's just fair, honestly, that's just technological justice. Second, the way to help students engage with these topics and concepts is to allow them to build their own projects and make change directly on the world. So once you've equipped them with all the right skills to make something, then let them learn free and let them try it. And finally, we wouldn't be able to do it at all without teachers, parents, and educators who help students connect to their passions and ideas. And so if this sounded kind of cool and interesting to you, I am actively looking for more teachers and educators to get involved, especially if the ideas about reaching students who are usually underserved by technology, if reaching underrepresented minorities or people in rural places, if all of that resonated with you, then please get in touch with me. You can find a contact form and more projects like this on our website at aieducation.mit.edu. And then also there's my Twitter handle, Randi_C1, where you can see other things that I'm up to. So thank you so much for your attention and for bearing with me in my solo dance. I think I'm allowed to take questions, so let me know if there are any.